What are the implications of these findings for the development of more efficient electrode materials for sodium-ion batteries? And how can in situ NMR spectroscopy be applied to other materials to gain similar insights into their sodium storage characteristics? What are in situ spectroscopy techniques? And how do they contribute to the analysis of the structural evolution of amorphous and organic materials, including the electrode/electrolyte interface in sodium-ion batteries? Can Davis Serinz manufacture solid-state sodium-ion batteries made from seawater in Latvia? How do Raman spectroscopy and FTIR spectroscopy differ in terms of their mechanism of action? And why are these differences important in studying bond vibrations and molecular structures during in situ analysis? What are the benefits of using non-destructive techniques like Raman and FTIR spectroscopies for monitoring the production and disappearance of unstable intermediates during charge and discharge cycles in batteries? And how do these methods help in understanding material behavior in real time? In what ways are Raman and FTIR spectroscopy complementary to each other? And why is their combination considered an advanced characterization method for studying electrode materials and interfaces in sodium-ion batteries? How does Raman spectroscopy work, specifically in terms of inelastic scattering of photons by molecular vibrations, and what does this process reveal about structural or molecular changes in the materials being studied? How does FTIR spectroscopy, through the direct absorption of photons by vibrations, provide insight into molecular dipole moment changes, and how does this affect its application in analyzing electrode materials in batteries? What are the key differences between the in situ Raman setup and the FTIR setup, and how do these differences influence their respective capabilities in studying electrode materials or interfaces in sodium-ion batteries? How does the optical window made of materials like quartz or calcium fluoride facilitate the in situ Raman spectroscopy of electrode materials and separators in button cells? And what role does it play in obtaining accurate data from the Raman laser? What are the advantages of using ATR mode in FTIR spectroscopy, and why is this mode commonly employed in detecting structural changes in electrode materials, particularly given the low energy of IR light? How can in situ Raman spectroscopy be applied to carbon-based electrode materials to investigate sodium storage content, binding sites, and the degree of order in these materials by analyzing the relative intensity changes of the G and D peaks in the spectrum? What role does Raman mapping play in characterizing the ligand metal valence states in Prussian blue and its analog materials, and how does it help determine the variation of sodium content during cycling? How?